All right, let's take a look through the example problems. All right, example number 1. Calculate the surface area of this regular tetrahedron to the nearest square meter. So that's going to be a whole number. Regular means all the faces are the same. Tetrahedron, tetra is 4. You should know that from science class. So we've got a triangle right here. And there are 4 triangles that are exactly the same size. So our first triangle has a slant height of 4.3 meters, and this base height is 5.0 meters. So I'm going to write out a formula for the surface area of a tetrahedron. Well, I have to figure out each triangle, so it's base times height divided by 2, and there are 4 faces that are exactly the same, so I'm going to times that answer by 4. So I've written out my formula. Now I write it down. My base is 5.0 times 4.3. I divide it by 2. Then I times it by 4. Now you should be able to type that straight into Desmos. I'm going to do a little bit of calculations here mathematically. This dividing by 2, I can cancel out to the 1, and the 4 can be canceled out to a 2. Right, if I'm dividing by 2, then timesing by 4, it's the same thing as just timesing by 2. And then I can do 5.0 times 2 is 10. 10 times 4.3 is 43 meters squared. And that is my answer for example 1. 43 square meters is the surface area of this shape. All right, example number 2. This is going to be a long and complicated example with lots of formulas. You're going to need to draw a picture for it. A right rectangular pyramid has base dimensions of 4 meters by 6 meters and a height, that is a perpendicular height, not the slant height. Calculate the surface area of the pyramid. All right, so let's draw out a picture of the pyramid. First, I draw a rectangle. And my rectangle is slanted because it's in 3 dimensions. Then I go over the middle, and I go up to a peak. And then I draw my faces. Sorry, my edges that go from the peak to the edge. This one that's in the back gets put on with a dashed line. Now, for my dimensions, I know that this is 6 meters here, 4 meters here, and I know that my perpendicular height is 8 meters here. I do not have any slant heights. All right, now first off, we are going to find out the area of this triangle here. And there are 2 triangles that are just like that. There are 2 faces. Here's the other one here. So we've got these 2. So I'm going to switch to black. And I need to figure out this slant height right here. This slant height. To do that, I'm going to complete this right triangle. Now, I'm going to pull this right triangle out so that I can see it better. I've got this right triangle right here, and it is 8 meters this way. And then I have to look at this length, right? This whole thing is 6 meters, so this is half of it, so this is going to be 3 meters. So now to figure out my slant height, which is this right here, I'm going to do my Pythagoras' theorem. My perpendicular height squared plus I'm going to call it my radius squared, is equal to my slant height squared. So we've got 8 squared plus 3 squared is equal to s squared. So this is 64 plus 9. 64 plus 9 is equal to s squared. 73 is equal to s squared. So s is equal to whatever the square root of 73 is. 8.5. Good. Now, I can figure out the area of these triangles. So the area of my two triangles, so I'm going to call this area 1, because it's going to be of these two triangles here. It's equal to base times height divided by 2. That's the area of one triangle. There's two triangles that are the same, so I'm going to times it by 2. It's equal to, you can see in this triangle the base is 4 meters. And then this slant height here is my 8.5 meters. So it's going to be 4 times 8.5 divided by 2 times 2. These are just going to cancel out, and I'm going to do 4 times 8.5 on my calculator. It's equal to 34 square meters. All right, now I'm going to choose another color. Now I have to do this triangle right here. I have to figure out the slant height of this triangle. So if we look here, the slant height comes along this face here, the front face, hits the corner there, like that. Now I'm going to draw this one out here. And we can see that this is 8 meters. Right? 8 meters tall, 8 meters tall. Then this right here will be 2 meters because this is 4, this is 2 meters. All right, now to figure out the slant height, we're going to do the same formula. H squared plus R squared equals S squared. 8 squared plus 2 squared equals s squared. Well, 8 squared is 64, and 2 squared is 4, so you get 68 is equal to s squared. Square root both sides. So I do the square root of 68, and I get 8.2. And now I can figure out the second area. Base times height divided by 2 times 2, because there's two triangles that are the same. The base is 6 meters times the height of 8.2 meters divided by 2 times 2. Right, these 2's are just going to cancel out. And I'm going to get 6 times 8.2. You might be able to do that in your head. 49.2 square meters. Notice how I'm showing all of my work here. All of my work is shown, it is labeled, it is easy to understand. Now we need to do the area of the base. The base is this rectangle down here. Sometimes you'll have to do the base, sometimes you won't. If it doesn't say anything, do the base, area of the base, rectangle, length times width, 6 times 4, area of the base is equal to 24 square meters. So in the end, my total surface area is equal to 34 plus 49.2 plus 24. So my total surface area is equal to plus 49 plus 24. 107.2 square meters. That's probably the most complex question you'll get when trying to figure out the surface area of a pyramid, a rectangular base pyramid where you only know the perpendicular height. So just to recap, what we did was we found the slant height using Pythagoras' theorem in that right triangle. Then we used that to figure out the surface area of the two triangles. And then we did that again right here. Used that to figure out the area of the two triangles. Then we figured out the area of the base shape and added all of those together. In the next video, we'll take a look at the next couple of examples.